I would like to present to you our preliminary results with application of wearable multimodal devices to study microcirculatory tissue systems under microgravity conditions. At this moment, we know almost everything about our systems sorry, could you, okay. We know almost everything about our systems and subsystems under normal conditions of gravity. But, however, the following questions remains unresolved, such as what happens to microvessels in zero gravity? How do they adapt to the redistribution of blood volumes between different parts of the body in order to ensure adequate nutrition of all tissues and the working conditions of astronauts? And what do we know about this, and how can we help people in orbit? The main goals of our space experiments was a study of tissue respiration processes, oxygenation, utilization by tissues, and microcirculatory blood flow in human skin under microgravity conditions. The experiment was carried out during a short-term expedition visiting to International Space Station, ISS, by two space tourists from Japan, and we've led by the spacecraft commander Alexander Misurkin. Just a little bit well-known information about the methods which we used in our space experiments. It was a laser Doppler fluorometry and fluorescence spectroscopy, both of these methods based on the laser light probing biological tissues. In LDF method, we registered index of microcirculation or perfusion, and very important that we can analyze microcirculatory rhythmic oscillations, which are very important and reflected mechanisms of regulation in blood flow. And in fluorescence spectroscopy, we registered normalized amplitude of fluorescence such confirmants such as NADH, and we developed a new complex parameter which we named oxidative metabolism index, which include both of these methods. And in our space experiments, we used a Russian development wearable multimodal device, LASMA, which include these two methods, laser Doppler fluorometry and spectroscopy. We use in Monte Carlo simulation for substantiation of diagnostic volume. Here schematically we can see a diagnostic volume for both these methods. The experiments includes three stages. Stage one before flight, during flight on ISS, and after a flight on train cosmonaut center. Experiments consist with pair measurements in 4 areas. You can see here with our 4 areas, and during for LDF signals, we registered 8 minutes. Here, I will try to start video. Yes, this is fast video with our experiments. We can see here Alexander Misurkin now produce this experiment. You can see devices now in the fingers and so on for these areas. And we haven't time, sorry. And our preliminary results is for microcirculation index. We can see very interesting, please take into account, 3 first days on ISS in this space. We can see some trends for all of our areas, and we can see the decrease index of microcirculation. This is was for a flight engineer. This is for a space tourist too. Okay, and very interesting that here we not to see so reaction, because these space tourists using a special device bracelet which attached on legs for defense from blood flow from limbs, from lower limbs to upper limbs. And very interesting result we can analyze in myogenic oscillation, because we can see some different reactions for skin temples, for example, and for lower limbs, I mean feet, toes, because again, blood flow going from lower limbs to upper. And this is results for another cosmonauts, and for cardiac oscillation, because again, if amplitude of cardiac oscillation is increased, it could be that arterial blood flow is more increased. And for we calculated nutritive blood flow, and again we can see a different reaction for fingers, for forearms, and for lower limbs, and for temples. And in the end, of course, we analyzed a fluorescence intensity, and very important that if amplitude of NADH, normalized amplitude fluorescence, is decreased, it means that metabolic processes doing with more high intensity. And again, in the foods, in toys, we can see another reaction. And our complex parameter oxidative metabolism index reflected these processes. In main conclusion is, first of all, the first time techniques has been developed for measuring microcirculatory tissue systems in the limbs of cosmonauts during the period of acute adaptation. And very important, we were able to see first 3-4 days when during acute adaptation, acute adaptations by microcirculatory tissue systems. For us, it's very interesting knowledge, of course, for our cosmonauts. And thank you for your attention.